Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Hi class, welcome to the SIC1004 Physical Chemistry Lab. Today we're going to talk on experiment 1, which is the acid-base titration. Before going to the experiment, I want you to actually look at all these videos. These are actually introductory videos to the lab on the safety issues and how you should use the apparatus and the glassware in the lab. And this is the link to the acid-base titration experiment setup. Now, if you look at the lab manual at the chemistry website, you will see that there's also, in addition to the lab manual, there is actually a data sheet. Now, this data sheet is a guideline for you to actually organize your jotter. So remember that in physical chemistry lab, what you get is a set of data, a set of numbers. So you want to make sure that the numbers are actually recorded, organized well. So this is just sharing with you one of the ways that you can actually organize your observation, and so that when it's time to actually transfer this to writing your lab reports, so everything look organized, and you can actually get the numbers and the data just from here and translate that to your lab reports. Now again, this is a guideline, and by the time you go to the second year and third year, this will not be provided. So so this is something that we want you to exercise. Although the sheet will be given and you may print this, I will highly advise the students to actually write directly to the jotter in this manner or in any style that you want, as long as it looks organized. Now back to the experiment. I'm sure this is not something new for you, but the only difference is that you didn't calculate the error treatment before. And on top of that, when I asked what is the number of decimal places that you should report on the molarity of a solution, and you answered 4 without really understanding why. So now I do hope that after that first lecture last week, you understood why we need to actually do the error treatment, so that we can actually know the number of decimal places that needs to be reported for any given values, and in this case for the molarity of solutions. So the objective is not limited to finding the pH curve for the titration for strong acid, strong base, and weak acid and strong base. You also the objective is also finding or the molarity, so in this or what they call the standardization of the solutions. So in any neutralization, what you have is actually an acid and a base, and you get water and salt. And so to gauge the titration, you use different indicators, and in our case we use methyl orange for naphthalene and bromotumon blue. These are the colors that you should actually look for when you do the titration. Anything that is, if you actually overshoot, depending on what you titrate with, these are the colors that when you actually overshoot. So the first thing that you need to do is actually standardize the sodium carbonate solution. As I said, standardizing means finding the molarity of the sodium carbonate solution. So this word accurate, way accurately about, seems to be contradicting with one another. But anyways, you weigh about 1.3 grams. Of course, your analytical balance is going to read up to 4 decimal places. And then you will transfer that directly to a volumetric flask, and this is just a guideline. You add some water and then you shake it so that it's dissolved, and then continue adding water to the volumetric mark, and then from there you can find the molarity of the sodium carbonate solution. Having that value, you can actually start standardizing the HCl. Now this will be done using metal orange as the indicator. Now the first time you will tend to overshoot because you have no idea what do you call you do not know how much hydrochloric acid that you need to use. So for example, if the amount that you use is 22 ml and it's overshoot, that means that the second time that you do it, you can actually open the tap of the burette quite fast, and maybe at 18 ml you start slowing down the tap, so open it very slightly, so that it will actually, the solution will drop, you start titrating drop by drop until you get to the accurate endpoint. And so you will do it better the third time. So perhaps so eventually what you actually need to average is actually the second and the third titration, especially if the first one is really overshooting. Okay, so once you get that, you can actually use the molarity of HCl to actually standardize a sodium hydroxide solution. And again, it's true with and the first time you do it with phenolphthalein and you repeat the process, sorry, the first time you actually do it with metal orange as indicator and you repeat the overall process with phenolphthalein as indicator. Again, it's true, first time if you overshoot, do not worry. That's what I will say to students in the lab, and just make sure that the second time there is a progression. So because I asked students to take pictures of their titration, what's the outcome of their titration for the first, second and third, so they will add these pictures in their lab report. So colors don't lie, so if they overshoot, it will overshoot, but all you have to do is just report that you overshoot, and you only take the average of the second and the third. So with that, you can actually standardize the acetic acid solution using first phenolphthalein as indicator, and you repeat the overall process with bromoethanol blue. Excuse me. So what you can see from here, that clearly that in order to get the molarity of acetic acid solution, you need to make sure that the molarity of sodium hydroxide is correct, and in return this one will also depend on the molarity of the hydrochloric acid, and this one will depend on the molarity of the sodium carbonate solution, meaning that if you mess on the calculation of the sodium carbonate solution, you're going to mess up the rest of this molarity. So students have to be very careful in finding the molarity of this one first, so that they don't mess up. Okay, so this is usually done in the first part of the experiment in the morning from 10 to 1, and then students will go for a break. When they get back from the break, they will do the pH curve for strong acid, strong base titration, and weak acid, strong base titration. And students are going to prepare 2 burettes, one with the standard sodium hydroxide solution, and the other is the sodium hydroxide solution, which is diluted 10 times. Why you have to prepare the diluted version is that you want to construct these pH curves. So you want to make sure that the buffer region, you can see the curve directly. Otherwise, there's going to be a quick jump between a low pH to the high pH, so you miss that really nice curve. So but then once you have actually do the recording, you have to actually convert back this diluted the diluted sodium hydroxide to the standard sodium hydroxide by dividing the values that you get when you use the diluted divided by 10. Okay, and in this case there's no indicator used. You're going to use the pH meter, which has been pre-calibrated for you by the assistant science officer. So usually we don't use a 50 ml beaker because it's going to be too small. We use a 100 ml beaker, and you will pipette this 10 ml of the HCl, and then you put in your pH meter, and then you start titrating with the standard sodium hydroxide first at pH. First you find the pH first of the HCl before you actually start titrating, and then you will start titrating with NaOH to get to pH 3. So this is just a guideline. It doesn't mean that you have to get exactly this, but it just tells you that at pH 3 use the standard sodium hydroxide. Then after that you switch to the, remember you have two burettes filled with standard and the dilute. So now you shift using the dilute sodium hydroxide, continue titrating until you get about pH 4, 5, and until pH 10. What it means here, you can actually get a few points for pH 4, maybe 4.1, 4.4, 4.7, and then you start getting 5.3, 5. So a few points. Remember, the more points that you actually get, the nicer the curve that you're going to actually construct. And by the time you get to pH 10, and then you switch back to the standard sodium hydroxide and you continue titrating until pH 12. It says here, attention, 10 ml of dilute solution equals to 1 ml. So you have to actually recalculate, convert back the dilute sodium hydroxide volume to the standard sodium hydroxide. For the pH curve for weak acid, you will also add 10 ml of standard the acetic acid into this, and then you also put your glass rod as a stirrer, and you also use the pH meter. That pH meter is not a stirrer, so that's why you use a glass rod, and you start titrating with the standard sodium hydroxide first at pH 3, 4, 5, and 6, and then switch back using dilute, to get pH 7, 8, 9, and then switch back to the standard sodium hydroxide, titrate with that to get pH 11 and 12, and you can actually plot the curve. Okay, so these are some of the pictures. These are actually students' work, standardization of HCl. Color of the solution changes from yellow to light orange at the end of titration, the presence of metal orange. So sodium carbonate solution, okay, that's and you add the metal orange because this is alkaline, this is yellow, but at the end point this is going to be orange. Okay, and if you overshoot, this is going to be red, so you don't want it to be red. And for the standardization of NaOH, using metal orange in this case, so the color of HCl solution, here, because this is acid, is going to be red, and at the end point it's yellow. Okay, and this is the standardization of NaOH using phenolphthalein. So at the so in acid, um, is colorless, but once you actually titrate with NaOH, it's going to be paler pink. If you actually drop more and overshoot, it's going to be really intense pink. Okay, and this is for acetic acid as well. So you want it to be light pink rather than intense pink. Now this is a situation, an example, and this is again done by students. Okay, this student, all the 3 titrations, they actually overshoot, and they realize their mistakes, that they what you want at the end point is actually green, but they actually overshoot up to, they thought that they should aim for this blue color, and I said what you want is the end point, and so you know that this is overshooting, so they had to repeat the process. So that's why it's very important to read your manual prior to coming to the lab and understanding what you need to do. Okay, so these are the given data, and again these are students data, and I'm not this may not be the best data necessarily, but this is just a guideline. This is just seeing how you actually treat the data. So this, given that the mass of the sodium carbonate is 1.3007, and this value of the error treatment is given in the manual of the analytical variance when it's actually when it was purchased. So we use that as the error, and that's quite good. It's quite accurate there. And this student, after doing the titration, so the average volume HCl used for the standardized of HCl with this solution is 23.50 plus minus this, and the average volume of NaOH used for the standardization of NaOH with HCl, in this case I just use this metal orange, is 8.70 ml, and for the standardization of acetic acid, the NaOH use is 10 ml. Now what you need to do, and this is in sequence, okay, as in the lab. So now what you need to do with all the values given is to find the molarity of all the solutions and show the error analysis. Okay, now for the pH curve of the strong acid and strong base, now this is okay, and as I told you, there are a few various at the range 1, at 1 you have a few range here, so that's why I said that the more points that you have, the better it is. So it started off with using the standard, so you have 2 burettes, so the students started with the burette with the standard NaOH. So these are the values. Okay, so what you need to do in constructing the pH curve, okay, the pH versus the volume NaOH used, is actually this table. So what you need to find ultimately is the addition, what is the consecutive, you're building up on the molarity of NaOH used for the respective pH solution. So then so from this to this, how much NaOH do you use, and so on. Okay, by the time the students get to page 3, they have to switch to using the diluted, and so these are all the values. So remember that if you get from here to here, okay, the amount is 0.1 mil, but that's 0.1 mil in what you call in diluted, so you should divide that by 10, so it becomes 0.01 mil of addition. So remember to convert this first to the standard solution before you actually add this up, and then you have to switch back to the standard, and so on. So you will be using this, so fill up this, and you need to complete this part, okay, of this chart, and use Excel, transfer these values to Excel, and plot it. Remember that this is a curve, it's not a linear curve, so I don't want you to actually have suddenly you have a curve and then you have a straight line in the middle. Let me understand what you're doing. Okay, so again, it's true, this one starts with this. For the weak acid strong base titration, you start with the standard NaOH, and then you swap to using the dilute to get this range of pH values, and then you swap back to the standard NaOH. So you need to fill up this part to find the value. Remember to convert this to the standard value by dividing the additional values by 10. So in the report contents that you need to submit, of course you should have a cover, title, name, and new metric number. And I would like to also add here, please add your picture as well, so that I get to know who is the owner of that. I get to see you in picture, and hopefully in the future live. And the objective, again, it's not just doing the titration curve, you're also finding the molarities of the solution. Make sure that you add that. Now, theoretical background or introduction, so I want you to spend no more than 1 page. So just talk a little bit on the essence of what this acid-base titration is about. And this is where you probably need some references, and make sure that whatever reference that you use, it should be cited. Okay, you should indicate in bracket where you get it from, what are the sources, and it should be referenced using APA style. So just Google APA style till you understand what it means. Now calculate the molarities. Straight away after that, just calculate the molarities of the then sodium carbonate, HCl, NaOH, and the acetic acid, together with the error analysis. Okay, the given Excel tables, please complete that and plot for both. And this is on the plot. So what do you observe from the plots? And so the conclusion, probably, which I didn't add here, is just to conclude by summarizing the molarities of all these solutions. Okay, and that's sufficient as a conclusion. So pretty much I want to see how you write, how you calculate, and how you report. And so this is due in a week's time. So by 30th, when we're going to have our next 2 labs, I should see your the first report in my email here. So please submit your lab reports to this email address, and make sure that the email subject is this, so that I recognize that this is from this lab, because I also will be receiving from other courses as well. So I want to make sure that it's clear which course this is pertaining to. Okay, so pretty much that's what lab 1 is going to be all about. So I do hope that you will really write a professional report, and make sure that your grammar, your English is good. And yes, so I'm looking forward to reading your lab reports. Okay, so that's it for today's experiment. Okay, and cover there. Okay, take care and stay safe. Thank you, and till next week. Assalamualaikum warahmatullahi wabarakatuh. Bye for now.